Good day, ECO152 students. Welcome to part 1 of the slides covering chapter 7 of your prescribed macroeconomics textbook. Today, we will learn about the Keynesian model of the economy with a government and a foreign sector. Remember, these slides and voice notes are meant to complement your textbook readings. For those who are using the first edition, please consult sections 4.7 and 5.4. Before you begin this chapter, it is important that you have a firm understanding of chapter 6, as this chapter builds on that. For additional worked examples, please consult page 82 to 87 of the ECO 152 exercise workbook. After studying chapter 7, you should know how to explain the Keynesian model with a government and foreign sector. You will also be expected to graphically illustrate and explain the model. As an extension from section 6.8, where the multiplier was introduced, you will be required to explain how the multiplier changes with the inclusion of government and the foreign sector. Furthermore, you should be able to calculate the equilibrium level of income. This chapter begins by relaxing one of the assumptions that there is no government. By relaxing this assumption, we now include the government sector, and this requires that we evaluate the impact of government, which we will denote with the capital letter G, and taxes denoted with a T, on a number of variables such as aggregate level of spending A, the multiplier alpha, and equilibrium income Y. This section of the chapter will be found in section 7.1 of the second edition, and if you are using the first edition, please consult section 4.7. In chapter 3, section 3.4, it was explained that the size of government spending is essentially a political decision. Well, what does this mean? Government spending is essentially guided by political objectives and not related to the level of total income, which is denoted by the letter Y. Government spends on social grants, healthcare, education, infrastructure, safety and security, to name just a few. We have seen over the last few weeks the rollout of various support mechanisms to business and households. An example is the increase in social grant payments over a 6-month period during a time when the economy is in fact contracting. We say that government spending is autonomous with respect to income Y. The G for government spending thus has a bar on top of it. When illustrating the relationship of government spending and total income, a horizontal line, G bar, indicates that government spending is autonomous or independent with respect to income Y. Note that graphically, government spending is on the vertical axis, G bar. This intercept indicates that government spending is autonomous. Hence, the line is horizontal to our x-axis, which denotes total income Y. This tells us that essentially government spending is independent of total income and points to the fact that government spending is essentially a political issue. Let's ask ourselves, how does government spending G affect aggregate spending, the multiplier, and the equilibrium level of income? The effects can be summarized as follows, and we will discuss it in the subsequent slides. Introducing G results in a higher level of aggregate spending. Secondly, it doesn't affect the multiplier, alpha. And thirdly, it will result in a higher equilibrium level of income, Y, ceteris paribus. In slide 5, we refer to figure 7.2 in your textbook. It shows the aggregate spending in an economy with a government sector. On the vertical axis, we now have aggregate spending A. And on the horizontal axis, we have total production and income Y. When an economy is in equilibrium, A equals Y, or aggregate spending equals total income. To illustrate this graphically, we draw a 45-degree line which shows all the points where aggregate spending is equal to total income. The horizontal line G, which we just discussed, represents autonomous government spending. The first aggregate spending function, that is this one over here, A1 or A subscript 1, is equal to consumption C plus investment I. And it has a vertical intercept or y-intercept A bar. It is important that you note the difference between aggregate spending A, note there is no bar on top of this A, versus total autonomous spending A bar. The vertical intercept A bar indicates all the autonomous components. Hence, they all have a bar on top of their symbols. So this A bar would be equivalent to saying it is C bar plus I bar. Equilibrium under a simple Keynesian model with no government added yet is given by E1. Now let's see what happens when we add G. From chapter 6, we know that the word aggregate means total. So to obtain aggregate or total spending, we have to add G to C plus I. We now have A is equal to C plus I plus G. Government spending thus raises aggregate spending. Note, aggregate spending over here, A1, aggregate spending A2, where we have included G. Graphically, we can see that the vertical distance between the initial aggregate spending function, A1, and the subsequent aggregate spending function, A2, is given by G. Right? That is the vertical distance between the two, which is equivalent to the distance from the origin to this G over here. Note, it is a parallel shift upwards of the aggregate spending function. Equilibrium is now established at E2 with a higher level of equilibrium level of income, Y2. Note, if we compare these two, there is a difference between Y1 and Y2. This initial level of income, Y1, occurred under the simple Keynesian model with just C plus I. Here we have Y2, which is given by this equilibrium position, which we have determined by the intersection of the aggregate spending function and the 45-degree line. And this includes government spending. Thus, A2 intersects or cuts the 45-degree line at a higher level of income, Y2. The vertical intercept, when I speak of the vertical intercept, I'm speaking about where this function cuts my y-axis or my vertical axis. So where it intersects the vertical axis, note that A2 with a bar on top now represents the total autonomous spending. This A bar now, A2 bar, it comprises C bar, I bar, and G bar. So what can we conclude from this diagram? Well, we can say that the position of the curve has changed, right? The position, it has changed. However, the slope or the gradient has remained unchanged. Remember, we know that by the fact that it has been a parallel shift. Remember that from chapter 6, you learned the multiplier is related to the MPC, or the marginal propensity to consume, which is the slope of the aggregate spending curve. With the inclusion of G, the slope has remained unchanged. Hence, the multiplier is unchanged as well. Now we need to look at the algebraic derivation. So total income Y is in equilibrium only when it is equal to aggregate spending A. There we go. Where Y is equal to A. That is your equilibrium condition. You should thus begin with your equilibrium condition always. Next, you need to substitute the components of A. That is C plus I plus G on the right-hand side of the equation. Right? So we know that we can expand the components of our consumption function to include autonomous consumption, C bar, plus induced consumption, which is our MPC times Y. Right? We've expanded those components. Now, all we need to do is to solve for Y, ensuring that Y is left on the left-hand side of this equation. So Y is now equal to autonomous consumption plus induced consumption plus autonomous investment and autonomous government spending. I can collect my terms by taking CY over to the left-hand side, and you know that when you take it over, the sign will change. I can now collect my terms, so now I have Y, and in brackets I have 1 minus C. Right? And note that on the right-hand side, all we have are the autonomous components, those components that have a bar on top of the letter. So that is autonomous consumption, autonomous investment, and autonomous government spending. Right? We have ensured that Y is left alone on the left-hand side, and we can now solve for the equilibrium level of income. Thus, by rearranging, we have Y0, which represents the equilibrium level of income, being equal to 1 over 1 minus C. This represents your multiplier, and in brackets we have all our autonomous components. We can thus summarize the formula as such: Y is equal to alpha multiplied by A bar. A bar meaning the total autonomous components, which is encapsulating those items over there. And this is your general multiplier formula.